Watch any football match today, and AI is tracking every single player, every single second, all at once. Welcome to This Explainer. Today, we're diving headfirst into the invisible game. We are going to explore the vision AI technology that has completely transformed how machines see, understand, and react to the physical world around us. It's a technology that has rapidly evolved from academic research papers right into the very fabric of our modern infrastructure. We're talking about everything from sports arenas to grocery stores to busy highways. Let's uncover this invisible layer of computer vision that is constantly operating in the background of our daily lives.
You know, when you or I sit down to watch a game, we just see the natural, continuous flow of play, right? But an artificial intelligence system, it is looking at something entirely different. It's constantly gulping down huge amounts of visual data to understand not just where the players are, but their exact posture, their speed, and even their shooting efficiency. It's honestly an incredible feat of engineering, and it's happening live, frame by frame.
Instead of watching a smooth video, the AI actually rips it apart and analyzes each frame individually, almost like a rapid flipbook of photographs. When you look at how it maps things out, you'll see these bright, colorful bounding boxes and skeletal lines drawn directly over the players in real time. The system uses some heavy-hitting deep learning models, stuff like YOLO and OpenPose, to lock onto the players and the ball while plotting out their joints and posture. And the craziest part? It's extracting this massive trove of performance data without a single wearable sensor on the athletes.
To actually pull this off, the AI has to run through a rigorous, lightning-fast checklist for literally every single frame of that broadcast. First up, image pre-processing. The system cleans the frame, fixes the lighting, and scrubs out visual noise. Next is object classification. This is where the AI looks at the shapes and decides, okay, is this a player, a referee, or the ball? Finally, we have localization. The AI pinpoints the exact coordinates of that object and draws a tight box around it. And remember, it's doing this for dozens of objects all at once, in mere milliseconds.
So, the real MVP enabling this real-time magic is a model called YOLO. And yeah, that stands for You Only Look Once. Older systems used to scan an image multiple times in different stages, which, as you can imagine, was incredibly slow. But YOLO, it's a single neural network that evaluates the entire image all at once, predicting where the boxes go and what the objects are simultaneously. Certain scaled-down versions of YOLO can run at a staggering 125 frames per second. It's the underlying engine that processes high-speed action without ever lagging behind the live TV broadcast.
But hey, just knowing where an object is in one split second isn't quite enough, is it? We need to know where it's going. That's where optical flow comes in. By calculating how pixels shift between consecutive frames, the AI can map out speed and direction. When you combine this optical flow with those skeletal detections we talked about, like tracking a player's ankle over a few seconds, analysts can dynamically monitor player agility, fatigue, and even how well they're covering their zone on the court. Okay, let's zoom out from the sports arena for a second, because the exact same technology tracking a point guard's jump shot is quietly entering our daily routines. In fact, your supermarket checkout might already be using this to charge you without a cashier. The translation of this tech from high-performance sports to your local commercial business is happening at absolutely breakneck speed. Using those exact same object detection principles, systems like Express Lane are looking at checkout lines to speed up your retail experience. So instead of drawing a box around an athlete, the AI slaps a bounding box around shoppers and shopping carts. It tracks throughput and bottlenecks dynamically, it monitors how long people linger in an aisle, calculates the length of the checkout lines, and can even alert managers to open new registers before customers start getting annoyed. It basically turns passive security cameras into active data-generating sensors. Behind the scenes of your shopping trip, an architecture is constantly churning raw video into actionable data. And here's a really cool trick. During training, developers intentionally mess with the images. They scale them, rotate them, and randomly change the color and brightness. Why? Because this data augmentation forces the neural network to learn what a person or cart actually looks like, rather than just memorizing perfect lighting conditions. That's what stops the AI from getting totally confused by a sunny window or a weird camera angle in aisle 4. Just think about traditional manual tracking for a moment. Picture a security guard staring at a wall of 20 monitors. Honestly, how long until human attention naturally degrades? Human monitoring is just inherently prone to fatigue and blind spots. Plus, if a big crowd crosses paths, a human might easily lose track of who is who. But Vision AI? It doesn't blink, it doesn't get tired, it flawlessly handles multiple objects at once, processing every inch of the screen with the exact same scrutiny at hour 12 as it did at minute 1. But what happens if you, the shopper, walk behind a massive display of paper towels? That's called occlusion, and it used to be a massive headache for AI. Enter algorithms like Deep Sort. It uses a motion predictor to guess where you should be based on your trajectory. But more importantly, it uses a deep neural network to extract your unique appearance signature, like the color and texture of your jacket. So if you disappear behind a shelf and pop out 3 seconds later, Deep Sort checks your signature, realizes you're the exact same person, and keeps your ID intact. Zero mix-ups.
And we're now seeing the scale to much, much higher stakes environments. The scope of this is just staggering. Industrial operations are using it to instantly trigger an alert if a factory worker steps into a danger zone without a hard hat. At airports, it's constantly scanning for abandoned luggage to prevent security threats. Out on the highways, it can instantly flag wrong-way drivers, logging vehicles, and sending alerts to stop catastrophic accidents before they happen.
Just imagine a freeze frame of a chaotic, busy city street. Every single car, pedestrian, and bike is instantly classified and wrapped in a colorful bounding box by the autonomous vehicles driving alongside them. This right here is the ultimate test for Vision AI. Because, in a retail store, a 1-second lag just means a slightly delayed customer service metric. But for an autonomous vehicle driving at 60 miles per hour, a fraction of a second of latency is literally the difference between life and death. The system has to process this chaotic, unpredictable world flawlessly, in real time.
To manage this immense crunch of data, companies like NEO are orchestrating massive AI inference pipelines directly on GPUs. Using tools like NVIDIA's Triton Inference Server, automotive engineers can move the heavy lifting off of standard processors and onto high-powered GPUs. In some of their core pipelines, this architecture has led to a staggering 6x reduction in latency and improved overall data throughput by up to 5 times. That is the sheer, uncompromising speed required to make automated driving a safe reality for all of us. So, from the sports we consume on a Sunday, to the way we grab our groceries, to the safety of our workplaces, and the self-driving cars of tomorrow, Vision AI is fundamentally reshaping our relationship with physical space. The technology is here, it is scaling rapidly, and its capabilities are only growing. Which leaves us with a pretty profound realization to take away from all this. The world is being watched in real time, and AI is doing most of the watching. Thanks for joining me on this explainer, and I'll catch you next time.